Thank you all for joining us today. My name is Jim Kaler with SCM Connections, and I'm joined by my colleague, Shane Kale. We're also fortunate to have with us today Chad Smith from the Demand Driven Institute. Chad's graciously agreed to give us a walkthrough of DDMRP to help educate us on the concepts and to answer some questions with us at the end of the webinar. We will capture questions in the chat. We're not going to have an audio portion for questions at the end, so if you have questions along the way, post them in the chat. We'll gather those up and we'll review as many of them. Thank you. So this is the first part in a multi-part series where we'll be discussing MRP. The goal of today's webinar is to present an overview of DDMRP and talk about where it fits in the IBP landscape. Shane and I, along with Chad, will be doing some future webinars that will cover deeper dives into the DDMRP process. We'll do some follow-ups from today's meeting about topics that you want to see in more detail. And Shane and I will also focus on leveraging SAP's integrated business planning solution of IBP and do the deep dives into that area. So without further ado, I'll hand over to Chad.
Thank you, Jim. I appreciate that. And it's great to be here today. I'm gonna go ahead and just dive right into the subject. I do have a fair amount of slides, and I'd like to make sure that we can get through them all and get to everyone's questions. Just a quick word on who the Demand Driven Institute is. Carol and I founded the Demand Driven Institute in 2011, just on the heels of the release of the third edition of Orlicky's Material Requirements Planning. And in that book, we introduced to the world demand-driven MRP. And we knew that there was going to be a vacuum, that people would want to know more about the method. So we founded the Institute. And since then, we've gone on to continue to write about the space. Our books define what demand-driven is, both from a broad and technical perspective. We provide thought leadership. We provide educational programs around the world based upon the demand-driven methods. We also provide professional endorsement certificates, software compliance standards. So we actually evaluate software to make sure that they're compliant to DDMRP standards. And we help proliferate the method through a large global affiliate network throughout the world. One thing that's important for people to understand is we are not a consulting entity. We are not a technology provider. We are an education and certification leader for the demand-driven space. Where I want to start is at a very fundamental level about what it means to be in business, what the objective of business should be if you're a for-profit entity, and what is going to be the ultimate determinant of how successful that is. And we're going to start with the concept of flow. Now, most people, I think, understand or kind of gauge what I mean by flow, but flow is really the ultimate determinant of success in business. When flow is occurring, we know that service is consistent, reliable. We know that revenue tends to be maximized and protected when service is consistent, reliable. We also know that inventories are minimized when flow is occurring. And we also know that all those additional expenses, things for overtime and premium freight and everything like that, additional freight, those expenses are minimized when things are flowing well. Those expenses go through the roof when things are not flowing well. And another thing that's important for us is when things are flowing well, we know that cash flow then follows the rate of product flow to market demand. And I think that that's a really important word, is the word market, right? Flow is dependent upon there actually being someone to take the product at the end of the line. And really what we get to is, if you just take a look at this: service, revenue, inventories, expenses, and cash. We know that when we protect and promote flow, what we really get is return on investment maximization. And I don't care what kind of business you're in, what kind of industry you're in. If you're a for-profit entity, you have one objective, and that is to maximize or drive return on shareholder equity. That really is the objective of every for-profit company. It's not to maximize profit. Why? Why do I say that? It's because people, investors, shareholders, they will forego profit now if they understand that their equity is increased today and in the future. So really, the primary metric that we should all be concerned about is return on it, some form of return on investment. And we know that flow is the ultimate determinant of how successful that objective will be. Let's explain it a little bit further. Let's see how we can connect flow to return on investment. This is an equation that we introduced in a book in 2014 that I co-wrote with Deborah Smith. And in it, we brought this equation out to get people to kind of understand the basic connection between flow. The first thing that we want to look at is, what is flow? Flow is the rate at which the system converts material to product required by a customer. Okay, that's a really key qualification. Cash velocity then is the rate of net cash generation. And this is our sales dollars minus our truly variable costs. And that's typically called contribution margin minus our period operating expenses. So a change in flow yields a change in cash velocity, which then yields a change to our return on investment. Of course, net profit over investment is the equation for ROI. If you want to understand how to quantify flow a little bit better, there are some equations to do it. We could say that there's one equation here: throughput times lead time equals your work in process. Or another way to say that, rearrange that equation, is your work in process divided by your lead time is equal to your throughput. Or your work in process divided by throughput equals your lead time. This is kind of the system dynamic of flow. Now, and I think some of you might have probably heard the term or the name Little's Law, but really what you have to understand is that these equations make one critical assumption, that that material or units are entering the system at the same rate they're leaving the system. Another thing that we can connect directly between flow is, or to flow, is what we call our company vitals. And our company vitals are your working capital, your basically how much captured money you have, how much available credit and cash you have, your contribution margin, which is your cash generation rate of your entity, and your customer base, which is things like your market share, your order book, and your service and quality reputation. We know that flow directly impacts all three of these company vitals. And there's another thing we know. We know that when things flow well through a period, cost is under control. In fact, if you look at any cost equation, cost is simply a measurement of past activity through a defined period. So when you think about it, if through that defined period, flow occurred well, we protected and promoted flow, then by definition, our costs will be under control. Another thing about flow is a common objective across many known and accepted disciplines. If we look at MRP, the objective of MRP was to synchronize demand and supply, okay? Flow is absolutely vital for the synchronization of demand and supply. If we look at lean, we have Taiichi Ohno. By the way, over on the left-hand side, MRP, that is Joe Orlicki, George Plazel, and Ollie White, all in a row. They're kind of the founding fathers of MRP. Now we have Taiichi Ohno here, where in the lean movement, we could say that the objective is to reduce waste. Now, I know if you're really into lean, you're going to say, Chad, that's not the objective. The objective is much bigger. And I get it. I totally get it. Except, let's be honest, the way that lean has been sold in North America and Europe is that its objective is to reduce waste. But you know what? By the way, guess what you need for waste reduction? You have to have flow. When we look at Ellie Goldratt here and the theory of constraints, the objective is to improve system throughput. Well, guess what? You can't improve your system throughput without increasing and protecting flow. And finally, we get to Deming, Six Sigma, where the objective is to reduce variability. Well, guess what? Once again, variability reduction is a result of better flow performance, all right? All of these objectives are dependent upon flow. And we even have a law that we call Plazzo's law. And what Plazzo's law states is that all benefits are directly related to the speed of flow of materials and information. And remember, George Plazzo was one of the founding fathers of MRP. MRP was all about flow. The problem is it never really achieved that due to some interesting things about the world. And by the way, those things are getting worse because now we're in what we call the VUCA world. All right, now VUCA stands for volatile, meaning the amplitude and the frequency of disruptions is increasing. Then it stands for uncertain, meaning that it's difficult to tell what will happen in the future. It's complex, meaning we have many more interconnections in our supply chains, in our entities, many more relationships to manage. In fact, if you think about it, our supply chains are elongated and fragmented relative to what they were 20, 30 years ago. And ambiguous. The world has become ambiguous as well. Now, ambiguous means it's not hard to tell what will happen. Ambiguous means it's hard to tell what is happening. Okay, so we have volatile, uncertain, complex, and ambiguous. And essentially, this defines the new normal for supply chains. If we look at supply chain characteristics back in 1965, we see all these different characteristics between complexity and life cycles, tolerance times, customization, variety. We see all that was a completely different picture in 1965 than it is today. It's night and day. Now, why did I pick the date 1965? I picked the date 1965 because 1965, we have the first acronym of MRP. That's actually when we developed the acronym of MRP. Now, MRP dates back to the late 50s, but it wasn't called MRP. It was called BOP, and then it was called DBOP, and then it became MRP. So by 1965, we actually had the rules of MRP laid down. And supply chains and the environment that they live in simply don't look anything today like they did in 1965. And these VUCA challenges, volatile, uncertain, complex, and ambiguous, this world challenges MPS and MRP systems dramatically. Why? Because as I mentioned before, the basic MRP equation has not changed since 1965. MPS was actually added on a little bit later to try to, let's say, buffer or filter or protect MRP from direct load of a forecast. Okay, so MPS and MRP, they work together, they hand in hand. But one thing that we have to understand is that MRP was never designed to manage stock. It was designed to be a perfect make-to-order calculator. And that's why it is designed to always net to zero. It is simply a calculator that says, you tell me what you need, and based upon that, I will explode through the bill of material, and I will tell you exactly what you need and when you need it to support that high-level demand. And I'm going to leave you with none left over. In fact, it sounds perfect. And that was the idea, was to be precisely perfect. But the problem is that MRP only produces a realistic schedule when there are three basic assumptions that are valid. One, demand is known and does not change. Number two, there is sufficient time to accomplish all of the required activities within the customer tolerance time. There's a rule in MRP that almost every company in the world that uses MRP breaks on a constant basis. And that rule for MRP to be effective has always been that your demand time fence should be set equal to your customer tolerance time. Now, if anybody that runs MRP is on the line, I would challenge you and I would ask you, do you have that set up that way? And the answer is no, you don't, because you don't feel you have enough time to be able to react if you set your demand time fence to customer tolerance time. And finally, MRP assumes that there's no variability in execution. In other words, everything, and I mean everything, must go according to plan for the MRP schedule to be achieved. Now we know that if we look across at almost any company's circumstances, we can see that these three basic assumptions are always tenuous, if not completely invalid in today's environment. We wrote an entire book about just this slide that I'm showing you right here to show you exactly what the problem was embedded in MRP systems and how to initially overcome the challenge. But this is it. This is undeniable. This is how MRP works. This is the assumptions under which it can work. The problem is those assumptions don't exist in 99.9% of the cases today. So 20 years ago, we had people say, maybe we should just throw it all out, just turn off MRP. And while I can understand the logic behind it in terms of if it's not helping us, it's making it harder, maybe we should just abandon it entirely. But and move to maybe visual and intuitive management mechanisms on the floor, maybe Kanbans, all right? The problem is that these mechanisms are extremely slow to react throughout large environments. And that's why oftentimes you see lean implementations compartmentalized to only certain parts of a company or certain parts of a plant. And relevant and timely information across these large environments is extremely difficult to get and discern and then and actually read what is actually happening and react to it soon enough. And the VUCA world just exacerbates these issues with lean. In fact, both MRP and lean don't deal with high variability very well. We've known that for years. That brings us to demand-driven MRP. And what is demand-driven MRP? It's a method to model, plan, and manage supply chains to protect and promote the flow of relevant information and materials, with the idea that that is a direct connection to return on investment. DDMRP uses strategic decoupling points to drive supply order generation and management throughout a supply chain. It's important that you understand what DDMRP is and what it isn't. It is not a management philosophy. It is a supply order generation and management tool that is part of a larger framework. We introduced demand-driven MRP, as I said before, in 2011 in Orlicky's Material Requirements Planning, the 3rd edition. And that was like the culmination of about 15 years of research and extensive application across a wide array of industries. Now, the unique thing about DDMRP is that we take kind of the best of many things and fuse it together. And the way that we make that fusion happen is through some key points of innovation that I'm going to share with you today. But we take the still relevant aspects of MRP, DRP, lean, theory of constraints, Six Sigma, and then we package it together, and it can hold together because of these critical points of innovation that I'm going to share. It can probably best be defined as position, protect, pull, adapt. That's DDMRP in a nutshell. There's 5 components to DDMRP. The first is what we call positioning. And by the way, it goes 1, 2, 3, 4, 5 for a reason. You don't just jump into 3. You don't just start at 2, you start at 1. And positioning is what we call strategic decoupling. Where are we placing key points of independence in the supply chain? Then, or product structure for that matter. Then it's when we find those points, then we have to protect those points. We have to build a sufficient level of protection to allow that decoupling effect to be maintained. Now we know that initial level of protection is going to change. It has to, right? Because we live in the VUCA world. So we've got to be able to make dynamic adjustments to that level of protection in advance of known things like maybe a plant shutdown or seasonality or a big promotion. And we've also got to be able to allow those buffers to adjust just based upon how the market is behaving. Maybe we're selling more this year than we were last year. Those buffers should be adjusting up. The protection level should be adjusting up. Once we have positioned and protected, then we actually get to the execution element, the pull, the mechanism itself. So we have what we call demand-driven planning. And in DDMRP, we carefully separate planning activity and execution activity. Planning for us is simply the notion of generating supply order requirements. And visible and collaborative execution is the management of those open supply order requirements, all of which relates back to the integrity of the strategic decoupling point. So I mentioned that there were some innovations that bring this package together that allow MRP concepts to live in kind of harmony with lean and TOC concepts. And I'm going to share those 4 basic innovations. Much of the demand-driven method is known and accepted, right? MRP, DRP, Lean, Six Sigma, and TOC. But what makes it all come together are these 4 innovations. The first of which is what we call decoupled lead time. See, in DDMRP, what I told you was the first step is to determine the decoupling points. And now we do that based upon 6 criteria, and we have some extensive examples in the book. But when we find those decoupling points and we declare them decoupled, there are major implications for lead time. See, MRP today only deals with 2 types of lead time, what's called a manufacturing lead time and a cumulative lead time. Manufacturing lead time says, if I have all my parts, it will take this long to build. In other words, it assumes full allocation across all child components. It assumes all child components are available. How often is that the case? Not so often. But then we have cumulative lead time. Cumulative lead time is really the secret sauce of MRP, because that's what it really uses to calculate. It says, okay, cumulative lead time is the longest path in time through the product structure. And if you really think about it, what it assumes is no child components are ever available. But the minute that we put in decoupling points, that assumption becomes invalid. So we create a new type of qualified cumulative lead time, one that is the longest unprotected sequence in the bill of material. In this particular case, we see that FPB, finished product B, has a decoupled lead time of 3 days. It's the manufactured lead time of FPB plus the longest unprotected path, which is SAL, or subassembly L. You can see all these other points are decoupled. So now instead of thinking either 1 day or a cumulative lead time chain that would go all the way down through here, now we're planning only for 3 days, because the assumption is that when we're decoupled, their components are always available. The next innovation in DDMRP is what we call the net flow equation. The net flow equation is how we generate supply order requirements against these decoupling points. The net flow equation answers 4 questions that every, and I mean every planner, is concerned about on a daily basis. The first is, what do I have coming in? The next is, what do I have available? The next is, what demand do I need to fulfill immediately? And what future demand is relevant? If you can answer those 4 questions as a planner for each of your items, you're doing great. The problem is, when you're using an MRP system, the answers are always changing depending upon when the MRP was run. In DDMRP, the answers don't change. The answers are immediate and they're intuitive. So the net flow equation is a very simple equation. It is my on hand plus my open supply minus my qualified demand. My qualified demand is sales orders that are past due, due today, plus qualified spikes. The next basic innovation is something we call decoupled explosion. Okay, now I told you about placing the decoupling points and what impact it has for lead time. I then told you about the net flow equation. That's how we basically determine requirements against a decoupling point. Now we get to how the decoupling points relate to each other. And this is what we call our decoupled explosion. We still take high-level demand and we explode it through, just like MRP. But whenever we encounter a decoupling point, and I'm going to put my little trusty pen on here, This, for instance, this is a decoupling point. Wherever we encounter a decoupling point, we stop that explosion no matter what. We allow that decoupling point to independently perform its own net flow equation and determine whether it needs resupply or not. You can see here, if it does need resupply, we explode back through the bill to the next decoupling points. In other words, this connection right here, SAA to SAC and SAD, it works exactly the same as MRP, except when we blow through SAC and SAD, we get to decoupled purchase components, and that stops the explosion. So decoupled explosion is a major aspect of DDMRP. The final innovation is what we call relative priority. And relative priority is both for planning and execution. And what relative priority does is it gives us a very quick way to tell us which parts are in trouble and need resupply or need expediting versus which parts don't need anything at all. You think about MRP, and MRP, I've always explained MRP as a very binary system. You're either okay or you're not okay. It's extremely difficult to tell just how not okay you are or how maybe too okay you are. And it's certainly very difficult to tell it relative one component A versus component B. But in DDMRP, both for planning and execution priority, we have 2 points of reference. The first is a color, and that's a general reference. So red means trouble, yellow means warning, green means good to go, all right? And then we also then provide a discrete reference, which is a percentage of your buffer that is either remaining in terms of on hand, that's execution, or a percentage of your top of your buffer, which is called your planning priority. That's your net flow position in your that yields your planning priority. And that will tell you if you have scarce material, if you have scarce capacity. It will tell you these are the parts you need to make before the others based upon this planning priority. Let's look at the critical differences between MRP and DDMRP. MRP, there's no such thing as a decoupling. MRP was never designed to decouple. It makes everything dependent in its calculation, and that forces longer planning horizons and variability accumulation. Now, you can toggle things in MRP to externally planned, right? You can say stop explosion here. The problem though that you're going to encounter is you have to restart the explosion. With DDMRP strategically determines decoupling points, or those strategically determined decoupling points compress lead times and absorb the bidirectional variability. In other words, DDMRP was designed specifically with decoupling in mind. MRP, it wasn't designed to manage stock positions. I said that before. It was designed to be that perfect make to order calculator, and it nets to zero. With DDMRP, it's designed specifically to manage strategic stock positions, and it never, and I mean never, nets to zero at those strategic points. I think that's a big point of differentiation. DDMRP is trying to net you to zero everywhere, all right? And by the way, safety stock just becomes the new zero, okay? But DDMRP never will net you to zero. In fact, if you're at zero at your decoupling point, you're not decoupled anymore by definition. MRP, most conventional safety stock and reorder point positions are static, set it kind of and forget it. What DDMRP designs in its stock buffers is they're dynamically adjusting all the time based upon past performance and or based upon anticipated future known events. Remember, MRP also attempts to keep full safety at all costs. Remember, safety stock, top of safety stock becomes the new zero. If your projected available balance drops one below that safety stock level, what do? We launch an order at minimum order, minimum lot size, and we expedite it. And what that ultimately means is we've got a lot of dead inventory and unnecessary expedites. Now, what DDMRP says is, wait a minute, why are we always trying to keep full safety? The point of safety is to be used. We can allow penetration into that safety zone. What we're going to watch is how frequently and how deep that penetration occurs. Penetration into safety is deemed normal in DDMRP, and we don't initiate immediate activity, or certainly we don't generate supply order requirements as a result of penetration into the safety. It's there for a reason. It's like telling somebody, don't sit on my couch because you might dent the cushion. The cushion is there to be used. MRP doesn't treat cushion like that. With MRP, forecasted demand signal input guarantees constant nervousness and expedite. Remember, we don't have enough time. Remember, to make MRP work, we're supposed to have our demand time fence set to customer tolerance time. Well, guess what? We can't do that. So what we do is we have our planning horizon extends out at least our cumulative lead time and beyond. And as real demand becomes known, we have to make adjustments. But the problem is we've already made commitments. We've already generated supply order requirements based upon the forecasted numbers. And now those adjustments cause recalculation with MRP, and everything below that component then is impacted both in terms of date and quantity. This is called nervousness, and it's been around since the dawn of MRP. It's just getting worse and worse. With DDMRP, supply order generation is tied directly to actual demand. In fact, one way to really understand how different MRP and DDMRP is DDMRP doesn't use a master production schedule. It doesn't need to. Instead, what it uses is something called a master settings or master configuration, which is how you set up and design the buffers, where you place them, and the level of protection they have. And if you think about MRP, MRP is all about priority by due date. Why? Because that's all we have. Remember, MRP generates this plan, and that plan is precisely full of quantity and dates. And it's, by the way, it's always precisely wrong. But DDMRP says, wait a minute, priority by due date really doesn't make any sense. That's just looking to manage activity. What we really want is priority by buffer status, because priority by buffer status is managing capability. It's managing integrity of the overall system flow. Here's some results, and this was compiled by our friends at Camelot Management Consultants, and they took a very broad brushstroke here across all the known publicly available case studies for DDMRP. And what you see here is, regardless of the industry, DDMRP is delivering significant results, both in terms of inventory performance, service level, and lead time reduction. I want to make it very clear, DDMRP is not an inventory initiative. It is a flow initiative that typically means your inventory will be reduced. But more than anything, it's about right-sizing your inventory at the right place to create flow. When you create flow, you have the right stuff and you don't have the wrong stuff. So typically inventory does go down, but service level also goes up. Look across the board. I invite you to go to demanddriveninstitute.com and go into the case studies section. Look at those case studies and you'll notice a constant and coherent theme. It is always service levels go up, inventories go down. What? How many years have we been saying that if we want increased service levels, or been thinking that increased service levels are tied to increases in inventory? DDMRP is proving the exact opposite. There's tons of case studies, as I mentioned before. We just had our Demand Driven World Conference in Amsterdam, and we had some excellent companies, some very well-known companies report on their journey with DDMRP. Many of these companies now have up to 45 facilities on DDMRP. You can see here with Michelin, you can see the results. Here's Coca-Cola, some excellent results from Coca-Cola. And by the way, I'll give you a hint. This has not been announced yet at all, but the videotaped presentation with Barry Anderson and Coca-Cola is now available on our membership section. Membership is free. We just uploaded it this morning. The presentation is amazing. You can see across multiple plants, they have people on video, plant managers, schedulers, planners, talking about the difference between how they used to manage and how they manage today. We also see Ninewood is an engineer to order company, and what they're doing, what they're able to do with demand-driven MRP and other aspects of the demand-driven operating model. And then finally, we have, this is from the steel world, these are steel service centers. You can see here across the board, whether it's ETO, consumer products, or distribution, you see fantastic results because we're changing the rules. We're getting rid of inappropriate rules and putting in appropriate rules. We also have an entire software community out there now. One of our jobs as the Institute is to evaluate software, put it through its paces, and make sure that it can perform all the compliance criteria for demand-driven MRP. You can see here we have a growing community, some very well-known add-ons as well as ERP products here that have made a serious commitment to this method and are delivering these types of tools and rules to their user base. Another thing I'm going to tell you that nobody else knows, so you're going to be the first audience to know this. We are going to be, every year we have our annual conference. In 2020, we're going to do 3 of them. We're going to do one for the Americas, we're going to do one for Africa, and we're going to do one for Europe. The first one is going to be in Houston, March 26 and 27. They will have 7 to 8 case studies, about 30 sessions. We're going to even have a track in Spanish. So if you really are wanting to know about DDMRP and demand-driven in general, and you're in the US or Canada, this is a must-attend event for you. And with that, I would say if you really want to go look at those case studies, we have presentations. I think we have about 45 to 50 hours of video content that's freely available, plus a ton of presentations that you can download that are freely available. Please go to demanddriveninstitute.com. And with that, I am done. So Jim, you want to take control back here, and maybe we can answer some questions?
Yeah, thanks, Chad. Shane, if you want to go ahead and set up for presentation. Shane and I will talk about how the DDMRP process fits into the IBP landscape and some of the capabilities within IBP. Again, if you have questions, please post them in the chat and we'll gather those up, and between Chad and Shane and I will answer as many as we can. Shane, do you have presentation capability? Okay. Great.
Take it away, Jim.
All right, thanks, Shane. Thanks, Shane. Go ahead and advance to the next slide. All right, so where does DDMRP fit in the IBP landscape? If you're familiar with IBP, most of you'll know most of these: control tower, sales and operations planning, demand, inventory, and response, all sit on the IBP platform, and they run on SAP HANA. DDMRP used to be part of the inventory or IO subscription, because when it first started out, it was only covering the first couple of steps, 1 and 2, where it was setting buffer sizes and buffer position. So it was kind of fit a little bit into this IO, which was multi-echelon safety stock. And they quickly realized that DDMRP was much more than that. You know, that SAP has taken a little bit of a different approach with the way that they release IBP, and that they don't wait until everything is ready. They release it in more of an agile process. And once they released the steps 2 through 3 and 4, and also 5 with S4, they broke out DDMRP as a separate subscription. Doesn't mean you don't need the other modules. You can run with DDMRP just by itself. However, you could also leverage S&OP to support the demand-driven sales and operations planning. And I'll talk a little bit about what's in the DDSOP. Demand forecasting is also relevant. While you don't rely on forecast, it can be an input into the DDMRP process for average daily usage, where you can use forecast, you can use history, or you could use a blend of the two. Demand sensing is also a valid input into the average daily usage that's a little bit more sensitive to open orders as part of the average daily usage. Control tower for web alerts would also be relevant to help monitor the DDMRP process. And then future state, there's going to be some DDMRP functionality put into response so that things could be done on more of an order-based level. So when you get down to execution, monitoring the open orders, we'll talk a little bit about what that execution is. Response would be the area that you would leverage for that. So then today, DDMRP exists in both IBP and S4, and there's a lot of overlap between the capabilities. DDMRP can be run in either system, and which tool is actually used for running your DDMRP process would be a part of your implementation. IBP connects to more than just S4, and there's capabilities within IBP, flexibility if you've used it before, that is not quite as easy to do in the S4 area. SAP's vision is that IBP will be the tool of choice for demand-driven S&OP, which feeds all of the inputs into the process and where you make your strategic decisions. Well, S4 will be the primary execution tool, but it'll be up to the implementation teams on where does DDMRP fit? Is it all in one or the other, or a combination of both? Next slide. Shane. So demand-driven S&OP, and thank you to Chad for permission to use this. This was pulled directly from the demand-driven, the DDMRP book. And this talks about where does S&OP fit in the whole process. You have execution, you have S&OP, and what type of activities take place there. The S&OP is a cyclical precursor to DDMRP. That's where you're going to set your company goals, and you're going to translate those into inputs that feed the DDMRP process. And you want to make sure you review those on a regular basis, because the inputs that you use for DDMRP are going to change. Your demand, you're going to go through your maturity model for your products, and you're going to, from a product launch to maturity to end of life, and you want to make sure you're capturing those types of feedback into your S&OP process. If you've got capacity constraints on long term, are you going to buy another machine? Are you going to schedule some other shifts? What are you going to do to make sure that when you do those releases from DDMRP to execution, that they're capable of executing those, and you're not going to impede flow by either starving or overloading your bottleneck resources. You're going to review the health of your system with, this is, Chad mentioned earlier that Six Sigma is part of the input into this. You're going to have statistical control charts that you're going to monitor and say, are my buffers performing the way that I want them to perform? And I want to know ahead of time when they start to drift out of alignment because my inputs are changing. I want to be able to react to those and make those adjustments and make sure that I have flow at the maximum in my supply chain. Then you're going to have your consensus is going to be reached in there with your different parties, and you're going to make those corrections in order to maximize your flow. That's the DDSOP portion as an input to the DDMRP process. And then the next slide, Shane. So what happens in the execution portion of it? There has to be a handoff somewhere. Every great plan that you come up with DDMRP and the suggestions for release actually have to have someone execute these in the correct sequence to make sure that you're getting the most out of your supply chain. Some of the inputs in here, we won't cover these in detail, but there are some things with control point scheduling where you can put some time buffers on your capacity to make sure that if you release several orders at the same time, they're still going to complete on time in order to keep your buffer levels where they need to be. Monitoring the status of your buffers, your synchronization alerts, lead times alerts. These are all the things that help you monitor your open orders and make sure that at the time that you released them, has anything changed in between, and make sure that the next one that you pull into either from procurement, the next one that they're going to ship, or from manufacturing, the next one they're going to produce, it's the most important one. And Chad mentioned earlier the step 5, monitoring these. It's not due dates that are necessarily the determinant of this. It's the relative priority, the color of the status, and the percentage of the status that makes it very easy to know which one to produce next. That's the execution portion of it, which is not currently available in IBP. That's an S4 activity, or the ERP system that you're attached to, because that's where you actually execute your open orders. To the next slide, Shane. What does that mean? We've talked about DDSOP. We're going to talk about DDMRP a little bit more with Shane and IBP and in the scheduling. So DDSOP feeds DDMRP. It also feeds the scheduling. This is where you made your decisions on how you're going to plan, how often you're going to order parts, how variable is your demand, how variable is your supply. You made your adjustments in your system and it's running, and your demand-driven scheduling on, you've identified your critical path, you've identified your bottleneck resources, and you made all of those different settings. So between DDSOP, demand-driven scheduling, you've got the bookends of DDMRP, and that's really, that's the handoff to the DDMRP, and Shane is going to talk about how does IBP support the DDMRP process. So Shane, if you'd like to take over and present the last portion of it. Thank you.
Yeah, and Chad had visited this slide earlier, but these are the 5 components that of the demand-driven operating model that are accounted for in IBP. So the first one being strategic inventory positioning of your decoupling points, which is the positioning and most importantly the first step. That's a precursor to protecting your inventory, and that's setting your buffer levels, dynamically adjusting for future events to kind of add some sophistication onto a lean, somewhere between a lean strategy and an MRP strategy. And finally, pull, where you are doing your demand-driven planning, calculating your net flow on a daily basis, and triggering recommended supply orders. And then the visible and collaborative execution, that's what Jim has been discussing, which is handled primarily in the S4 side, and that's tracking your projected on-hand alerts and material synchronization, things like that. And that's where the handoff between IBP and S4 occurs. As far as IBP, one of the algorithms is the recommended decoupling points, where IBP will calculate where your strategic decoupling points need to be placed across the entire supply chain network. The way that the algorithm works is it uses buffer profiles and other master data elements to not only calculate the strategic decoupling points, but also how much inventory to position at each of those points. So these buffer levels are recommended based on the decoupled lead time, which you can see here in the web interface. We have a decoupling lead time here for material F10A at location 1010 for 3 days. So the system will automatically calculate the decoupled lead time based on where that inventory is positioned within your supply chain. And this web application that we're viewing here also shows the average on hand in quantity and in dollars or whatever monetary value you're using in IBP. And it enables users to also run simulations on part decoupling point adjustments. And you can review the results very easily in this web application. Within IBP, there's also the Excel user interface. So where you can visualize which of your decoupling points were selected by the recommended decoupling points algorithm, along with calculating the buffer levels, which are split into the green, yellow, and red zones here. And in our next webinar, this is where we're going to focus on that first component, the demand-driven operating model, which is where to set our strategic decoupling points. And to set your strategic decoupling points, it usually comes down to 6 positioning factors, which can be automated and accounted for in IBP's DDMRP functionality. Customer tolerance time, so this would be setting your decoupling point within the customer tolerance time so that you can meet demand strategically. Same thing with the market potential lead time. This allows you to expose an increase in revenue or winning a new customer based on where you're positioning a decoupling point. Sales order visibility horizon. So if you have a very short sales order visibility horizon where customers order within 2 days, but the cumulative lead time is much longer than that, then the system will recommend a closer decoupling point to be able to meet those sales. IBP also calculates external variability both on the demand and the supply side to protect inventory where it's very susceptible to VUCA-like conditions. Inventory leverage and flexibility. So if there's a component that's shared across many different finished goods, that's also an area where you can leverage DDMRP to possibly have an assembled order strategy, which can help lower your inventory and improve your ability to meet customer orders. And finally is critical operation protection, where you might have a bottleneck resource that you don't want to starve or overload. And so these are the 6 components that we'll focus on in our next webinar for how we can manage strategic decoupling decisions within IBP. So that is all for today. Feel free to contact us to learn more. Reach out to Tim and myself and Chad, and also visit our website, scmconnections.com, to learn more about us. And we thank you all for attending and watching this afternoon.
Thank you, Shane. We did have one question. Hopefully, while we're answering this one, maybe we get a few more. So, Chad, there was a question on the different zones. So the red, the safety zone, the yellow, the lead time, the green, the order frequency zones. Can you talk a little bit about what does it mean when you're at the top or the bottom of each of those levels?
Sure. You know, each zone of the buffer has a specific job to do. Green is all about the ordering, really the ordering mechanism. It's the order size. It's the minimum order size, and it kind of tells you your typical average order frequency. Yellow is basically one kind of period of supply. You can think about that. It's lead time, it's demand times full lead time, decoupled lead time. And then your red zone is safety is reserved for variability. What we do for planning is different than what we do for execution. In planning, we are creating supply sufficient to be at the top of the buffer, so the top, all the way at the top of the green zone. That doesn't mean your on hand goes that high. What it means is that's your plan to level. That incorporates open supply on hand and demand, known demand. With regard to the red zone, when we're in execution mode, we are looking at the on-hand position of the buffer relative to that red zone. Now, we don't plan, our average on-hand inventory should be what we call top of red plus half of green. But we will expect that on hand will dip down into that safety. So in execution, we're just looking at on hand penetration to that safety. And penetrations are not a big deal. It's the severity and the frequency that we watch over time to determine whether we need to make an adjustment on the buffer or if we have to jump in and order an expedite. But the thing is if we do jump in and order an expedite, we're not launching a new order. We are expediting an already existing order. And so it's a lot different than what you're used to with a safety stock mechanism.
Thank you, Chad. We had another question on, is there a tool to detect decoupling points? And the answer is yes. Within IBP, there is a job that will, based on some of the feedback that you give the system, some of the parameters that you set, it will look through your supply chain, through your bill of material and say, this is where you should be holding decoupling points based off of the strategies and the inputs that you created there. It typically does a critical path analysis and then says these are the places in order to meet your goals where you'd want to set those.
Don't be afraid to use your head either.
That's right. Planners always know something that the system doesn't.
Exactly.
Most intimate with their product, right?
And salespeople might know something that the system doesn't too.
Another question: does demand-driven replenishment override the safety stock? Chad, you want to field that? I know we're running short on time.
The short answer is yes. If you're running DDMRP, you are not running safety stock.
Okay. In the interest of time, we are coming up at the top of the hour. Happy to, if you send us more questions, we'll be happy to post those as part of the link. And there's a couple of other questions that we had listed that we were going to cover that Chad will do a short answer to, such as who could benefit the most from DDMRP, what kind of supply chains, what kind of hurdles do companies face implementing, what kind of change management, what kind of culture needs to be in place. Some short answers on that. I'm sure there's hour-long or couple hour-long webinars we could do just on those questions. But we want to make sure we can help assess on whether DDMRP is right for you. And in most cases, the answer is yes, but is it right for you right now? And that's what part of what SCM Connections does for you is looking at all of the IBP options and where are you today and what kind of roadmap can we use to get you there. There was another question on product segmentation, and yes, we'll be looking at product segmentation and analyzing decoupling points in our next session. So thank you for that question. I want to thank Chad for taking time out of his schedule to help talk about this. I know he's passionate about it, loves to get the word out, and we love having him as a guest on here, and we'll be hearing from him some more in the future. I want to thank everyone for attending today. But please feel free to reach out to us, any questions that you have that come up afterwards, and we will send out a link to the attendees where we will be posting the recording and the follow-up answers to the questions that you send us. So, thank you all.